Today we want to keep talking about coordinates. If you recall, we want to describe each point in R2, that's our abbreviation for two-dimensional space, with two coordinates. Since we're in 2 dimensions, we need 2 coordinates. When we're in 3 dimensions, we need 3 coordinates, and so on. But right now we're going to limit ourselves to R2. We have 2 coordinates to describe the location. We have 2 styles of coordinates. We've got our original coordinates, the rectangular coordinates, where we use 2 distances, a horizontal distance and a vertical distance. They make little rectangles. That's why I have those orange lines, making little rectangles. We can also describe these this location with polar coordinates, where we have 1 distance from the origin and an angle through which we rotate. So I could list the coordinates of this point as xy, or I could list the coordinates of this point as r and theta. It actually makes more sense to do the theta first and then the distance, like rotate through the angle and then go a distance away. The theta that we have here is in standard position, just like we have the origin of our coordinate system at 0, 0. That's the standard position. We just have to decide where we start. And we decided to start counting theta from the positive x-axis. So this is where theta is equal to 0 degrees. And counterclockwise is positive angle measure. That's standard position. Here's what we want to do. We want to figure out how to draw right triangles. We want to connect our right triangle trigonometry, all the stuff that we know about right triangles, all of our trig functions, our Pythagorean theorem, that stuff. We want to put that into these coordinate systems. We need a place to put the right triangle. That's what we need to do today. We need a place. We need to figure out a way to put a right triangle into this picture and use in coordinates. If we look at the diagram we have up here, we've got an x on the horizontal, a y on the vertical, and r on that angle of theta. If we pull those pieces out, there's the origin. I have an x down here. I have a y going up and down. I have my r, and I have my angle theta. Here's where we're going to put our right triangle. Now we're going to have to figure out what happens if theta goes past 90 degrees. For this, we're going to introduce the concept of the reference angle. We're going to want theta to connect. We're going to want theta to connect to the x-axis. If theta is over in the 2nd or 3rd quadrants, we're going to drop down to the negative part of the x-axis. This is not in standard position. We're just using this for a reference. Reference angles are going to measure from the terminal side to the nearest part of the x-axis. I forgot to say from the terminal side. a reference angle is going to go from the terminal side to the nearest part of the x-axis. What this does for us is gives us a right triangle. It gives us some theta reference that's related to our original theta that we can put into a right triangle. So that's the goal here. So it gives us a theta sub r, a reference angle, related to theta, it gives us a reference angle that's related to theta that we can place in a right triangle. The reference angle will go from the terminal side, the nearest part of the x-axis. The x-axis only has two parts, the positive x-axis and the negative x-axis. Remember what we're trying to do? We're trying to take some theta in standard position and make reference to some other acute angle that we could put into a right triangle. If we've got a theta in the first quadrant, in quadrant one, the reference angle is just the angle. That's just the picture that we pulled from our original. That's where we're going to put the right triangle. So we'd say that the reference angle is just the angle itself. In quadrant one, theta is already an acute angle, and we can already put it into a right triangle. In quadrant two, if we've got an angle with the terminal side in quadrant two, we want to go from the terminal side to the nearest part of the x-axis. So we're just going to drop straight down to the negative x-axis because that's where we could put a right triangle. Our reference angle is going to be 180 minus the angle theta. Our reference angle is going to be in here. Notice I didn't put a direction on the reference angle. It's just an acute angle. That's where we're going to draw the right triangle. We're just trying to take our old stuff and stick it in the new stuff. Old stuff being right triangle trigonometry. We're just trying to take that and put it into this coordinate business. In quadrant three, If theta has a terminal side in quadrant 3, then we're going to go back once again to the negative x-axis. So here is where our theta is going to be, or our reference angle. We're going to take theta and subtract 180. Because theta has gone past 180, we want to go back to the negative x-axis. In the fourth quadrant, we have an angle that goes all the way around to the fourth quadrant. Then we're going to keep going until we get back to the positive x-axis. So that's going to be 360 minus our theta. What we want to do is imagine where the reference angles are. The reference angles always go towards the nearest part of the x-axis. Don't worry about memorizing how we find them with these formulas. That's just demonstrating what they are here. What we want to be able to do is figure out what a reference angle is for any angle. So for example, if theta is a negative angle, it's in the fourth quadrant, then we're going to want to change the sign. But the reference angles always get attached to the nearest parts of the x-axis. So our reference angles are going to be in here. It's the reference angle bow tie. Official name for it. I'm just kidding, that's not the official name for it. Every time I draw this, I think it's Darth Vader, like trying to get Luke. Going back and forth. And all of a sudden, it's like moving all the time. And all of a sudden, I have you now. And he totally didn't. Why is it that throughout the whole movie, Darth Vader is just like using the force all over the place? And then the one place where he could have used the force, he relied on the computer. What the hell, Darth? And then someone said, like, well, he had to make it look like he was trying, right? But who's going to call him on it? Like, if you're like, Darth, why didn't you take the shot? Are you really going to walk up to Darth Vader? It's like, oh, dude, I saw you had him. Why didn't you take the shot? I mean, that's how you get force choked by Darth Vader. It's like, oh, why didn't you take the shot? I mean, those will be your last words. It'll be like, oh. right? And some people are like, oh, well, that's because he knew that was his kids. Like, oh, he didn't know that in the movie because nobody knew that at that point in the movie. George Lucas hadn't made that part of the story up yet. He was like, oh, he just got the second was like, hey, what if Darth Vader was Luke's father? And like in the second movie, he's like, wow, did you plan that? It's like, oh, you didn't know that? It's like, oh, no. It's like, oh, yeah, I've been planning this the whole time. It's like, you know, it doesn't make sense even with the first part of this movie. But anyway, that's all beside the point. This is how we're going to take the thing that we're familiar with, right triangles, and put it into coordinates. How's everybody, okay? Take a break. So our goal is to take the stuff that we have, right triangle trigonometry with sine, cosine, and tangent in terms of opposite, adjacent, hypotenuse, and start putting it into coordinate systems. So we want to connect this new thing, these coordinates. We want to, and polar coordinates and rectangular coordinates, we want to connect that to what we already know about the trig functions. So here's the triangle from the previous page. We got the x coordinate and the y coordinate because we're looking at this point with coordinates x, y, or in polar coordinates, this point is r theta. So in terms of x, y, and r, well, actually, in terms of theta, what is x relative to theta in this right triangle? Adjacent. So x is adjacent. And what is y relative to theta? Opposites. And what is r? Hypotenuse. So even though xy is some point in two-dimensional space, we can build this right triangle and make things familiar. That was the goal. Build the right triangle, make things familiar. So it is, since sine of theta is opposite over hypotenuse, what is sine of theta in terms of x, y, and r? Opposite y over hypotenuse r. What is cosine of theta in terms of x, y, and r? Cosine is adjacent over hypotenuse, so x, oops. X is adjacent, r is hypotenuse, so cosine of theta is x over r. Tangent of theta is what in terms of x, y, and r? Y over x, opposites over adjacents. We also have x, y, and r related with the Pythagorean theorem. X squared plus y squared is equal to r squared. And we can turn these around to convert from rectangular coordinates to polar coordinates. We also want to think about reference angles while we're doing this. So let's consider the point -4, 3, and let's write that in polar coordinates. Now, the trick with -4, 3, what quadrant are we going to land with -4, 3? We'll be in the second quadrant because x is negative and y is positive. So if I draw this point, if I go negative, I didn't put enough negative. So there's the point -4, 3. Here's r. And in polar coordinates, our angle should be in standard position. So here's r. Theta needs to start at the positive x-axis and come around to the terminal side. So polar coordinates put theta in standard position. This would be the positive value of theta. Notice that theta, since we have an angle in standard position in the second quadrant, theta is bigger than 90 degrees. Theta is not an acute angle. So we want to grab the reference angle for theta. If we start doing calculations with these x, y's, and r's, we're going to get angles that are inside this right triangle. So if we look at pull the right triangle out of here, we've got a base of 4, a height of 3, and our hypotenuse of r. Theta is not sitting in this triangle. It won't fit in a right triangle. What we have is the reference angle. We will get information about this reference angle. So when we start setting up trig ratios with opposite adjacent hypotenuse, we're going to be, those ratios will involve the angle, the reference angle for the angle theta. So what can we do to find the radius? For polar coordinates, I need a radius and an angle. How do we find the radius? What should we use? Pythagorean theorem, because we just got this triangle. There's a 3, a 4, and we got to figure out the r. So I'll just go 3 squared plus 4 squared is r squared. I don't know why I think this color coding is throwing off my processing power. I should probably drop it, free up some hard drive space or free up some RAM, but I'm not going to. I'm also distracted because I didn't get to make my copies today, so we're going to be finished early. I know everybody's going to be mad that we get out of here earlier than normal. Dude, we paid for a 3-hour class. So what is r equal to? 5. That's why I picked 3 and 4. So we've got half of our coordinates already. What could we do to find theta using the 3 and the 4, or even the 5? But using the 3 and the 4 specifically, what can we do to find theta? What trig function involves this angle and the 3 and the 4? Tangent. So I could set up a tangent of the reference angle is the opposite over hypotenuse. So if I want to know what the reference angle is, I can just tangent inverse my way to the reference angle. I'll get my calculator machine. So our reference angle is tangent inverse of 3/4. But this 36.9 degrees is a reference angle in the second quadrant. So what's the, if we have a 36.9 degree reference angle in the second quadrant, what's the rest of it? What's the theta equal to? So theta, how do we figure it out? (180) minus the 36.9 degree reference angle. Because we're in the second quadrant. So I'll just do 180 minus this angle. So the coordinates -4, 3 correspond to a radius of 5 and an angle in standard position of 143.1 degrees. Questions? What we're trying to do is put coordinates, take coordinates and combine it with the thing that we already know. Because this is always what we do in math class. We just take the thing that we already know and adapt it to the new thing that we want to do. Let's take what we already know and adapt the new thing that we're trying to do. Questions? Comments? Slide you want? Thoughts? How's everybody? Okay? I gave back a test today. You're really mad at me for taking off points just because your answer is wrong. What a dick move. And it was only a practice test, so calm down, man. All right, here are the things that need to happen for the rest of the day. Number one, make sure if you didn't get it earlier that you pick up your practice test. They are up here. Organized by last name if you have more than one thing. They'll be up here. And upside down. Ooh. Number two, let's take another quick break until Thursday at 1 o'clock. That'll be it for today. I told you we were going to be done early today because I didn't have my conference. And it's freaking me out, man. All right, that's it for today. I will see you all on Thursday. Everybody have a good couple of days. Try to stay dry. And thanks for playing.